Here we go. Yep. Yep. Testing. Here we go. 1, 2. Yep. Yep. Testing. Here 1, we go. 2. Yep. Yep. Testing 1, 2. Testing. Here 1, 2. Yep. Bram, do you just want to say something quickly? Yep. Testing 1, 2. Testing. Here 1, 2. Yep. Bram, do you just want to say something quickly? Yep. No. Testing 1, 2. Testing. Here 1, 2. Yep. Bram, do you just want to say something quickly? Yep. Audience can't hear you. No. Testing 1, 2. Testing. Here 1, 2. Yep. Bram, do you just want to say something quickly? Yep. Audience can't hear you. No. Testing 1, 2. Testing. Here 1, 2. Yep. Bram, do you just want to say something quickly? Audience can't hear you. No. Testing 1, 2. I can hear you. Audience can't hear you. No. Testing 1, 2. I can hear you. Audience can't hear you. No. I can hear you. Audience can't hear you. No. Just want to say something again quickly. Just want to say something again quickly. Nope. Just want to say something. I can hear you, the audience can't. Nope. Just want to say something. I can hear you, the audience can't. Alright, I'm going to do something really nasty. Just want to say something. I can hear you, the audience. Do you want to say something quickly? I'm going to do something really nasty. Just want to say something. I can hear you, the audience. Do you want to say something quickly? I'm going to do something really nasty. No, that doesn't work either. Just want to say something. I can hear you, the audience. Do you want to say something quickly? I'm going to do something really nasty. No, that doesn't work either. Just want to say something. I can hear you, the audience. Do you want to say something quickly? I'm going to do something really nasty. No, that doesn't work either. Just want to say something. I can hear you, the audience. Do you want to say something quickly? I'm going to do something.
Yeah, can you hear me? Working now? Yeah, can you hear me? Right.
All right. Thank you to everyone for bearing with us while we worked through those audio challenges. Always the way with these things. We have, many technical challenges, I suppose, even in the industry doing, day-to-day work. For those who missed out, my name is James Westall. I'm your host for Azure Security Meetup. This month we have with us Bram from the Netherlands. He's going to take us through Azure Container Security and core setup for that platform. So I'll stop gasbagging about that, but I might pass over to Bram to take us through that.
Hi, James. Thank you. Hi, everyone, and welcome to this meetup where we'll be talking about container security. more specifically about image vulnerabilities and how we can countermeasure those. Just a quick introduction about myself. My name is Bram. I live and work in the Netherlands for Bryte as a cloud native engineer. Bryte is an Azure-focused IT service company with a specialization in DevOps, open source, and Kubernetes. After I spent a lot of years in process management, I changed my focus back to the tech side around 5 years ago, where I started out as a Linux engineer. At an assignment back then, I had to build a platform for running their first containerized workload, and this had to be done on Azure with Kubernetes. I didn't have any experience with both, so that's where my journey with Azure and Kubernetes started. So I had to learn Azure Kubernetes from scratch, and little did I know anything about security with regards to containers. So in the past year, I also dove into the security side of containers, and I like to share what I know so far, what I've learned, and I applied so far. I'm still not a security expert, but I hope that this talk and demo will help you guys out in making your containerized workload a bit more secure. So enough about me, let's get started. I will first explain what the core components are of container technology, and then I go into the major risks per component. So this will give you an overview of all the security aspects that you need to think about. For this session, we will dive deeper into image vulnerabilities and what you can do to countermeasure them. And at last, I will demo how you can scan your images during build time, scan them within your container registry, and how you can integrate that with Defender for Cloud and Azure Sentinel. Like James, I had some technical issues. It seems like since the rebranding of Azure Security Center to Defender for Cloud, the image scanning part and sending it to Defender doesn't work correctly anymore. I have a running incident with Microsoft for it. So for the demo for today, I will show a pre-recorded demo from about a month ago. So you will get a good view of how it should work. So when we talk about core components, there are images that we build within our pipeline. We have our registry where we save our images or where we push our images to. We have our orchestrator like Azure Kubernetes service. And then we have the container itself, so that's the running instance of an image. And of course, the last one, the host, which are the virtual machines where our workloads are running on. Now we're going to look into the major risk per component. For the image component, we have a couple of major risks, and those are vulnerabilities. When you build your image, you can build it and make sure it's all without vulnerabilities. But eventually, vulnerabilities will be found and your image will be insecure. The image can also have configuration defects, like that your image is configured to run as root, which is a defect. Embedded malware is a risk. Malicious files could be embedded within your image. Clear text secrets is a big issue. You should not hardcode any username and passwords or SSH keys or certificates within your image. And also the use of untrusted images is a big issue. As you all might know, on Docker Hub you can find so many images that you could use that may seem like a good solution for what you're looking for. But if you do not test it, you do not know what's in there, which could be a big risk for your complete environment. Then if we look at the registry, if you have an insecure connection, so not an HTTPS connection to your registry, that could lead to a man-in-the-middle attack, and your credentials for logging into your registry, or even the image contents can be fetched by the person who does the man-in-the-middle attack. Still images is also a big risk. Once you build your image, and you push it to your repository, you may create and push new images or new versions of that image, but the old one still stays in the repo, and are potentially still be deployed to your environment, and those still images can have vulnerabilities that are not fixed. And also insufficient authentication and authorization restrictions is a issue. Of course, you can imagine that if you give everybody full permissions to your registry and everybody can just push and pull and delete images, whatever they want, causes a big risk to your environment. Then we have the orchestrator, unbounded administrative access. If you give everybody the admin access to the cluster, and people do not know what they're doing, could be a big risk to your environment. Then we have unauthorized access. A lot of times, like with AKS, you can use Azure AD for your user management. But if you choose to use users within Kubernetes itself, and somebody leaves the company, probably there's a process which makes sure that the user will be removed from AD, but that user will still exist on the cluster and still has the kubeconfig file. So the person who left the company would still have access to the cluster. Sure, you can imagine that you do not want that. And then we have poorly separated inter-container network traffic. You do not want a internal finance application to be able to connect with your public accessible workload. By default, all containers are able to connect to each other. With network policies, you can make sure that not every container can connect to each other. So yeah, if you do not integrate that, there's also a big risk. And the mixing of workload sensitivity levels. Again, if you have the important internal finance application running on the same node as a workload that's accessible from the outside, is also a potential risk. Then for the container, you can build your image and make sure it's vulnerability free. But once it's running and new vulnerabilities are found for certain base images or your image, those vulnerabilities will occur in your runtime software as well. So you want to look out for that. Unbounded network access, you want to make sure that, for example, again with the financial application that runs internally, maybe does not connect to the outside world. Maybe only needs to connect to applications within your cluster. So you have to restrict outbound access when necessary. Insecure container runtime configuration is a big risk. And your application can also have vulnerabilities itself, like cross-site scripting, for example. And then to the last component, the host. Automatically, a host has a attack surface, and if you use an OS that's is not only meant for running containers, you have a larger attack surface. And of course, your workload shares the kernel on that host, which also means a larger attack surface and a risk to your environment. And your host OS components itself can have vulnerabilities, which is also a risk. And improper user access rights, if you give everybody permissions to SSH into your host machines, that could potentially be a threat to your environment as well. And host OS file system tampering, if you allow mounting important host directories into your containers, that could be potentially a risk for your environment as well. So I hope this gives a bit of an overview of the core components of container technology and what major risks there are. So you have a little bit of an overview of what to think of when you think of security, container security. And for today, we're going to deep dive a little bit more into the image vulnerabilities, which is one of the major risks for the image component. And to countermeasure the image vulnerability risk, you want to scan your images. You can scan your images within your pipeline, so at build time. You can scan your images in your container registry, which can be done with Defender. And you want to make it visible. It will not automatically solve anything, but at least it will give the team visibility into the vulnerabilities that have been found and hopefully trigger people to pick it up and solve it. And you want to implement quality gates. So you would like to have a policy that would say if my image has a certain severity, like a high or critical, I don't want it. I don't want the build to succeed, and I do not want my image to be pushed to my registry. And the same goes for the runtime. If your image has certain vulnerability, severity, like high or critical, you do not want it to be deployed on your environment. And you can set that with like Azure policies for your cluster. So today I will demo these steps. So what I will demo is with GitHub Actions, I will show you how you can scan your image during build time. And how you can configure the GitHub action to actually fail if it has a certain severity threshold. And then I'll show you how you can enable scanning within your registry, in your Azure Container Registry, and how we can integrate that with Defender for Cloud and Sentinel. And the Sentinel part is more for alerting you if vulnerabilities are found within your image. So that also gives some visibility. And also last, I will also show you how you can create a dashboard within the Azure portal to have an overview of your vulnerabilities as well. Like I said, it seems like with the whole rebranding from Azure Security Center to Defender for Cloud, the part where you post your scan results from your build to Defender does not work at the moment. I have an incident with Microsoft and they are investigating it. So right now I will start a recorded demo that I gave about a month ago. So it's going to show you the exact same things that I was planning to. So let me switch. James, can you acknowledge that you see my screen with the demo recording, maybe? Okay, cool. So I will start the recording where I start the demo. First, what we'll do is we're gonna, maybe if you don't see it, please refresh your screen. Yeah. I don't know if this is readable for everybody. Yeah. Okay. So what we first do is we're gonna scan, or we're gonna build an image, and during the build, we're gonna scan it. So I have a small Docker file here. It just takes the latest Nginx image, and we'll just copy an index file in there, and that's it. So here we see the flow. First, we're gonna check out the repo. I'm gonna build the container. And then we're going to use the Azure Container Scan task. I will later go into it a little bit more deeply. And then we'll do a login into our container registry and push the image to our repository, Azure Container Registry. So let me just the version here so we can trigger the build. Then we should see an action that has been triggered here. since we're using a host, it's already started. So here it's building the image. It's done here. You can see that it's scanning the image for vulnerabilities. And the image has been pushed to a repository. So if we go over here, we see that the scan task, it marks it as failed. I will later on explain why. Here you have a short overview of how many vulnerabilities it has found. So you can see it has found 2 criticals and 16 high vulnerabilities. And it also gives some best practices regarding your Docker configuration that I will explain a little bit later as well. And here you see an overview of all the vulnerabilities that it has found. If you go to the step here, then you see a little bit more detailed information. So here you see each vulnerability that it has found. So you see the CV ID, you see which packet it's about and what severity it is, and a description of the vulnerability. You can look up the vulnerability, the CV ID online, and check if there's a fix for it and how to fix it. So the task that it uses is the Azure container scan task. You can find it on the GitHub Action Marketplace. And here you have the configuration explained. So you give a name for the image that you want to scan. You can set the severity threshold. In this case, we set it to high. That means that all vulnerabilities of high and higher, so also critical, are being showed within the logs of your build in the scan task. Then we have the run quality checks. This is set to true. What it does, the agent, the scan task uses Trivy from Aqua underwater to scan your image, and also Docker, which is a container linter. And it also does some CIS benchmarks. So it checks your Docker file against it as well. So this is just the task that it uses. And in our repository, we can see, I think it's this one. Yes, see at 10:15, this image has been pushed. But now we have a image that's being pushed to a repository with vulnerabilities. So it could be that people push images to your registry without using GitHub Actions and without using the container scan task. But also images within your container registry can have, when they're older, can go stale and miss CVEs. So you would also like to scan your images in your registry as well to make sure that you have an overview if there are images with vulnerabilities. The way to do that is with Azure Security Center. Oh, is this clear for you? Can you?
I can see it.
Yeah. Okay. Yeah. Clear. Okay. Cool. So what you first need to do is enable Azure Defender for your container registry, and it's done on subscription level. For me, it's already enabled. Watch out if you enable it; it takes about 24 hours before it's actually doing something. So this is enabled, and then we can see in the recommendations, remediate vulnerabilities, and then we have vulnerabilities in container registry. We see here my container registry, and let's see which last image, 62C. See if it's already scanned, picked up. Apparently not yet. Let's refresh. It can take a couple of minutes for the container registry to pick up the new image and to scan it. And let's see if it already found it. This one, yeah. So here we can see that the image that we just built has been scanned. You see here the Azure Defender uses the Qualys scanner. You see that there's a big difference in the amount of vulnerabilities it's found through the Qualys scanner and the Trivy scanner. At the moment, I don't know what causes this big difference, but ask them both how this is possible. You already see here that you can also can connect your GitHub action with your Azure Security Center, so you can get the scan results from your build into Security Center as well. So that's the next demo that we'll do. So what it does, we just add a new task to it. What it does, it sends the scan results to our Azure Security Center, and it does this via a connection string and a token. And if you want to know how to get that within Azure Security Center, there is integrations, and here if you click on configure CI/CD integrations, you get that connection string and the token, and that way you can use it to send your results to Security Center. So now let's enable it, and then we're gonna trigger the task again. So when we go back to GitHub, we see that it's starting again. So it's done building, scanning the image again. Of course, it's gonna find the same vulnerabilities as it did before, because we didn't change that much to the image. But it's about the new task that it added, the post scan to Azure Security Center. So the image has been pushed. And it has been posted. So let's see what the, so F55 is the tag. Let's check if we can find it in Security Center again. At the recommendations, remediate vulnerabilities. And I don't think it has been scanned yet. Let me check. F55. Oh. No, not there yet. So let's refresh. What we'll see is once it has been scanned, you will see the overview of the scan results from the Azure Defender. But next to it, you will also find an overview of the scan results from the build. So you have everything nicely in one place. And let's see if it's already there now. The fun part with demos. Resources. No, it hasn't been scanned yet. Always nice to see. But what will happen? We can take another one that I already did before. What you can see here is you can see the vulnerabilities by severity through the Azure Defender scanner, and here you can find the findings that have been discovered during the build time. The only thing is that it refers to the GitHub action and the results in there, and hopefully in the future they will integrate it and add those vulnerabilities underneath here, where also the Azure Defender vulnerabilities are found. So it's integrated, but halfway there. So hopefully in the future that will be there soon. So now we have our images being scanned in our registry as well. But what if we want to block an image from being pushed to our repository because it's not compliant, then within the flow, right now I have continue on error true. So even though the image is not compliant because it has high vulnerabilities or higher, it still proceeds with the build steps. But if we here change this to false, save it, trigger it again, and then we will see that a new flow will start. And then we'll see that once it does the scanning, it will then fill the complete build. Busy scanning at the moment. Taking a little longer than we hope. Always the fun part with demos. Yes, live demos. Refresh. No. Okay, this is always the fun part. But you will see what I can show it here in an earlier one. That it scanned the images and it scanned the image, but it found vulnerabilities high or higher, and it completely fails the build. It will not do the push to the registry anymore. So the image will not be the image with vulnerabilities will not be in your container registry. Be careful with implementing it. I would suggest to let it continue on error at the beginning and see what kind of vulnerabilities you get. And in the first 2 months, get the insights into it and see if you can remove those first before you really block developers from working. But yeah, this is a great way of bringing the whole security part to the left, so as early as possible within the development life cycle. So a developer could pick it up right away instead of running into issues in production, which costs way more money, of course. Let's see. I don't know if it's, oh, sorry. Here we see, so it scanned and it failed. So this works nicely.
It felt like expected.
Yeah, it failed as expected. So now that we have, we see how we can scan our images. So normally, if you would block it, no images with vulnerabilities would be pushed to your registry. But people, of course, can push images, or maybe people can push images to your registry without using the normal build pipelines. Or your image is going stale. You want to use Azure Defender to scan them, but you might want to get alerted when a scan finds some vulnerabilities. So I will show you how you can do that with Security Center and Sentinel. What we can do, or what we have to do, in Security Center, we need to enable the continuous export and send the security recommendations for vulnerability in Azure Container Registry to a log analytics workspace. So that data, those recommendations will be posted to the log analytics workspace. Make sure that it's a log analytics workspace that's also being used for your Azure Sentinel environment. And then we have enabled this. It will add an extra table in your log analytics, which you can then query and alert on. So if we go to Azure Sentinel, we're going to create a playbook. And let me just create it in my Onion resource group. I'm going to call it Image Vulnerabilities. No spaces. And then you see here it automatically creates the Azure Sentinel connection. It validates, and then we create it. And once it's created, it will go straight to the Logic app, where we can create a action And in this case, we will create an action that we will get alerted in Teams whenever a vulnerability is found. We can use the Teams integration, and we will post a, let me see, post a message in a channel or chat. Need to quickly sign in my Teams environment. Then here you can choose post to a channel. Of course, you can use whatever action you want, but for this case, we'll just simply notify ourselves within Teams. And just have a vulnerability found. Save this one. Now we have the logic app, but there needs to be some a rule behind it to check what does it need to alert on. So we're going to create a analytics rule, and we're going to create it. We're going to call it image vulnerabilities as well, and we're going to enable it, and we're going to use the KQL query command language. What we do here, this is the security nested recommendations, is the table with the recommendation information or logs sent from Azure Security Center to the log analytics that we just enabled. And then we're going to check for our container registries, and then we're going to query on the high and critical vulnerabilities. And we want to check that every 5 minutes. And we're just going to look at the last hour of data. For now, we're not going to create an incident, but you can also create an incident if you want. And now here we can choose an automated response, and then we can create the logic app that we just created. Going to validate. Going to create it. So once we created it, this will do the query in the background. If it finds the results more than 0, it will trigger the logic app and it will alert us. So if we look at the active playbooks, you can see that I just enabled it, but it already performed a query. So just a minute ago. And then if we look in Teams, we can see that here we've got notified about the results of the scan. So this way you can use Azure Security Center and Azure Sentinel to alert if you have any vulnerabilities within your container registry images. Okay. Another way to make it visible is to create a dashboard within your portal that you can share with your team, and you can query in here. I will show what query it is. I'll explain it a little bit as well. So what this query does, it checks that recommendation table again, checks for the high and critical vulnerabilities, and then I just project some default columns that I want within my dashboard. When you run it, just let me check. Here, you can also pin it to your dashboard. In this case, I'll just pin it to this one. And then we should see, if we go to dashboards, here you have an overview of all your images, all your registry images and their vulnerabilities. In this way, you can share with your screen or report about the vulnerabilities that you have found. So this way, we can scan our images during build time. We can scan our images within our registry. We can prevent images from being pushed to our registry when they have when they do not meet the compliance fee that we configured, and we can alert. So this was the demo that I gave. Hopefully the demo gave you a good insight on how you can scan your image, like so before within your build during build time, but also within your container registry, how you can how you can implement the gate at build time to prevent your image from being pushed to your registry, and how you can make it visible by using Azure Defender and Sentinel to create alerts, but also the Azure portal to create dashboards with an overview of your vulnerabilities, which hopefully should trigger teams to pick up those vulnerabilities and go fix them. I hope you learned something and you enjoyed the demo. And if there are any questions, then please let me know. Do you see any questions coming in, James?
Sorry. I personally have a question, and I think hopefully we'll get some from the group as it comes in. In terms of content outside of the GitHub, tool chain, right? For maybe like local validation of vulnerabilities, or how would you go about that before even pushing it to a repo? Is there a way to do that for the teams who are building containers?
Yeah, the container scan, the GitHub action, which contains which scans the image, uses Trivy underwater, and I can show you. Check. Oh, my keyboard is not working. It's like everything is going wrong today, eh?
It's one of those days.
Yeah, one of those days. So Trivy is an open source tool from Aqua, and you can run this locally and already scan your image before you even use it within your build, or before you even build it with your pipeline. So this is also a great tool to just use it locally, and it's just a one click away tool to use.
Yep. So you can validate local images with Trivy.
Yep.
Yep. Cool. And obviously, you built a dashboard in Log Analytics. Are you able to track over time, like your posture using that same data? Like, in terms of I had 5 vulnerabilities on Tuesday and 20 on Wednesday, sort of scenario?
Yeah, probably. Then you need to create some different dashboard that keeps track of it, of the amount. I haven't created a dashboard like that, but I imagine that it's possible to create it as well. But then you need to be maybe a little bit more experienced in creating the dashboarding within the Azure portal.
Yeah, I suppose probably.
But that's possible, because maybe you would like to see an overview of the amount in need over a certain period of time to see if you're progressing in removing those vulnerabilities. Yeah.
Yeah, I suppose probably a conversation to look at time series data and that's exported for each form.
Yeah.
I don't think we've got any questions from the group. We do have feedback, obviously saying it was a great presentation. Thank you for coming through. A big thank you to everyone who has tuned in and bared with us through technical challenges. Always the way with these things. Appreciate you coming through to talk to us. For those of you who are watching, the Melbourne community is getting together again on the 15th. Not the security user group, the just standard Azure user group for an IoT session. So we're going to have someone come through and talk on an IoT journey after 10 years of putting IoT into their personal life, and also have someone talk through the Azure IoT use case. Is even today using containers, right? So probably some security lessons you could take from today and apply to that.
Yeah.
For the new year, we have a dual session for January, hopefully for Melbourne at least. It will be the last online only session, and then we can probably go back into in-person sessions. That'll go up shortly. But until next time, everyone, thank you for tuning in and have a lovely evening.
Thank you for having me, James.
Cheers, mate. Talk soon.